Hey everyone, so welcome to this video, and in this video we'll talk about BFS algorithm. Okay, so BFS stands for nothing but breadth first search, and in this algorithm we traverse the graph level by level, right? So this is level number 1, this is level number 2, and this is level number 3. Okay, also we make use of one more data structure, that is queue. So this is a queue, right? So let's see the steps that we need to follow while traversing the graph using BFS. Okay, so these are the steps that we need to follow. So the first thing is we need to mark the root node as visited. So let's say if I want to execute the BFS algorithm on this graph, okay, and this is the root node, okay. So what we need to do, we mark the root node, that is node number 0, as visited. So this is the first step. After that we need to push that root node inside the queue. So what I'll do, I'll push 0 inside this queue, okay. This is step number 2. Now after doing that, we need to create a while loop and execute these set of commands inside this while loop, right? So the first step here is to get the front element from the queue. So the front element means, let's say if I insert 4, 1, then 3 and 2 inside this queue, okay. So here in this case the front element is 4 right now because 4 is inserted first. Let's say if I pop out 4 from this queue, okay, now 1 becomes the front element, okay. Let's say if I pop out 1 again, then 3 becomes the front element. The third step is to get the front element from the queue and store that element inside a variable, okay. So let's say if 3 is the front element here, then we need to get this element and store that element inside a variable like temp, okay. After doing this, we need to print out that element. So we'll print 3 here, and then we need to pop out that element from the queue. So 3 will get popped out from this queue, okay. So these are the steps that we need to follow, and after doing all these steps we need to create a for loop and execute these steps, right? So let's say if 3 is the popped element, okay, now we'll create a for loop here and traverse that node. So let's say if 4 nodes are connected with 3, right? Let's say this is node number 1, then we have 2, then 4, and let's say 7, right? So we need to visit all these nodes. We need to visit 1, 2, 7 and 4 and check whether that nodes are visited or not, right? And if that nodes are visited, so we'll do nothing, and if it is not visited, so we will mark that node as visited and push that node inside this queue, right? So this is a step that we need to follow inside this for loop, and the condition that we need to write here is queue is not empty, that is we need to run this while loop until the queue becomes empty, okay. So these are the steps that we need to follow while traversing the graph using BFS, okay. Now let's run the BFS traversal on these graphs. So let me rub this first. Alright, so what I'll do, I'll push this node, that is node number 0, to the function which is calculating the BFS, right, and mark this node as visited, okay. Now the second step is to push that element inside the queue. So I'll write 0 here, okay. Now the condition that is written here is queue is not empty. So here queue is not empty, so this condition is satisfied. So now we are inside this while loop, and the first thing that we need to do is we need to get the front element from the queue. So here the front element is 0, so we'll store that element in some variable, let's say temp, okay, and after that we'll print this element, okay. So I've printed here. Now after printing that element, we need to pop out that element from the queue. So let's remove this element, okay. Now, so this is the for loop, and we just need to visit the adjacent nodes of temp, right? So here in this case adjacent node is 0, so we need to visit the adjacent nodes of 0. So here in this case it is 3 and 1, okay, and check whether that node is visited or not. So if that node is unvisited, so we have to mark that node as visited and push that node inside this queue, right? So let's visit the adjacent nodes of 0. So the first is 1. It is unvisited, so we'll mark this node as visited and push 1 inside this queue, right? The second one is 3. We'll mark this node as visited and push 3 here, correct? Now for loop is completed. We'll go to the starting point of while loop because queue is not empty, right? And we'll get the first element, the front element from the queue. So here the front element is 1. We'll print 1 here and pop out 1 from the queue, okay? And again we just need to visit the adjacent nodes of 1. So here in this case 3 and 2, but 3 is already visited, so we'll visit 2, okay? And mark this node as visited and push 2 inside this queue, right? And again we'll go to the starting point of while loop because queue is not empty, and so we just need to get the front element from the queue and store that element inside a variable that is temp, okay? So here in this case 3 is the front element, so we'll store 3 inside this variable, right? And then print 3 here. After printing 3 we just need to pop out 3 from the queue, okay? And again we have this for loop, so we'll visit the adjacent nodes of 3, and here in this case it is 0 and 1, and that are already visited, right? So this if condition will not get executed, and now we are at the starting point of while loop, and again we just need to get the front element from the queue. So here in this case it is 2, so we'll store 2 inside this variable, right? And print 2 here. After that we'll pop out 2 from the queue, okay? Now the queue becomes empty, okay? So this condition is false, and now we are outside of this while loop. So, and this is the output, this is the BFS output, that is 0 1 3 and 2, 0 1 3 and 2, right?